Hi dears, welcome to Brilliant Qatar JEE Mantra Series Chemistry Part 7 Recap video. In this video, we are mainly focused equilibrium as well as thermodynamics. So the two chapters important concepts we are going to discuss. So these two chapters are very important for the JEE purpose. So they will ask minimum one question from each chapters. Both are mathematically important chapter also. So that's why from integer type question you can expect some questions also from here. Okay. So let's go with the questions. See, let's go with the recap ideas. So here the important ideas from thermodynamics is actually mainly we have to focus what is intensive property and what is extensive property, and what is state function, what is path function, then internal energy. Then first law of thermodynamics, that means that equation delta U equal to Q plus W. Then enthalpy, H, okay, that is delta H equal to delta U plus P delta V. But for mainly chemical reaction, delta H equal to delta U plus delta NGRT. Delta H is equal to QP. Delta H is equal to what? QP. That idea we must have to remember. Then heat capacity, spontaneity, okay, and Gibbs free energy and entropy. Delta G equal to delta H minus T delta S. Then temperature dependence on spontaneity. Then enthalpy of reaction. There are so many types of reactions are there. They are enthalpies, like enthalpy of formation, enthalpy of combustion, and bond energy, enthalpy of atomization, enthalpy of vaporization, enthalpy of sublimation, lattice enthalpy. Like there are so many enthalpies are there. At least mainly you have to remember these three. Then Hess's law. These are the important ideas from the chapter thermodynamics. Now let's look about one by one. Okay, ready? So here first one, intensive properties and extensive property. Intensive properties are the properties which are independent of amount of substance. That means whenever you are dividing a system into two, that property remains unchanged. Then that is what is called intensive property. Like density, okay, intensive properties, density. Okay, density is an intensive property. Refractive index is an intensive property. Specific capacitance, specific conductance, that's specific. We are telling something specific. Okay, so specific heat capacity, molar heat capacity, etc. belongs to what? Intensive property. And what is extensive property? That depends on the amount of substance. Whenever you are dividing a system into two systems, that time that properties are changing. Like mass, number of moles. Okay, mass, number of moles. Then what? Then volume. Like that properties are belongs to what? Internal energy, Gibbs free energy, entropy. All are what kind of property? Extensive properties. That idea you must have to know. What is intensive, what is extensive, like that ideas. Okay, you have to keep it in mind. Next again, state function and path function. State functions are the functions which depends only on the state functions means which depends only on the initial state as well as final state. But path function means initial state, final state as well as the path followed. So here path functions, mainly two path functions you have to remember. First one is work, second one is heat. Other than that, mainly they are belongs to what? State function. In this thermodynamics, we have to learn about internal energy. It's a state function. Enthalpy is a state function. Gibbs free energy is a state function. Entropy is a state function. Like that. Okay, you have to keep that idea in mind. Next again, we have to remember about the relationship between delta H and delta U. Delta H equal to delta U plus delta NGRT. This delta NG is very important. Delta NG. Why I am keeping that NG? NG means for gas. Delta NG is nothing but it is the number of moles of, number of moles of gaseous products. Okay, gaseous products. That gaseous is very important. Okay, gaseous product minus number of moles of gaseous reactants. Number of moles of what? Gaseous reactants. Okay, number of moles of gaseous product minus number of moles of gaseous reactants. That is what is delta Ng. And that itself we have to remember. If case 1, I am taking case 1, if delta Ng value equal to 0. For example, like H2 plus I2 reverse, H2 plus I2 gives 2Hi. This equation I am taking, this is gas, this is gas, this is gas. In that case, delta Ng equal to 0. that time I can write what? Delta H should be equal to what? Delta U. That idea you have to keep it in mind. Okay. And case 2, if delta Ng value is positive, greater than 0, meaning then delta U plus some value we are adding, then we are getting delta H, meaning delta H is greater than delta U. And case 3, what about case 3? Delta Ng value is less than 0. If delta Ng value less than 0 means from delta U, you are subtracting something, then only you will get delta H. That means delta H value is less than delta U. This much idea you have to keep it in mind. Okay, clear? Ready? That related question may come. Clear? Yeah. We can move to the next idea. That is what is calculation of work done. Work calculation sometimes they usually used to ask, especially isothermal process for their work. Okay. So in the case of isothermal process, work equal to minus Q. Why? Because we know, see, listen to me, delta U equal to Q plus W. That's a formula we are having. Delta U equal to Q plus W. That's the mathematical expression for first law of thermodynamics. Okay. So here for isothermal process, there is no temperature change. There is no temperature change means that internal energy mainly depends on temperature. So delta U become equal to 0. Q plus W equal to 0. From that work equal to minus Q I will get. Now, once we are calculating work done for a reversible isothermal expansion, that time you have to remember in the case of isothermal, reversible means that pressure is continuously changing. We already learned that idea. So, work reversible is equal to what's the formula we have to use? Minus 2.303 nRT log V2 by V1 or else P1 by P2 also you can use. No problem. N means number of moles, R means universal gas constant, T means temperature in Kelvin scale, V2 is the final volume, V1 is the initial volume. Okay? Yeah. Or else work done in a isothermal irreversible expansion. If it is irreversible expansion means continuously a same constant pressure is applying. That time work irreversible is equal to what's the formula? Minus P external. External pressure into change in volume. That formula you have to keep it in mind. That related question may come. Clear, dears? Next, we can look about heat capacity. Heat capacity is the amount of heat energy required to rise 1 degree Celsius of any substance. And if we are discussing that one, if you are defined that one for 1 mole substance, 1 degree if you are raising for that, how much energy is required, that is what is called molar heat capacity. Cm equal to Q divided by N into delta T. Suppose that N equal to 1, delta T equal to 1, Cm equal to Q. Clear? Yeah. Similarly, if you are defining that one for 1 gram. So, for 1 gram substance, 1 degree rise in temperature, how much heat energy you have to give? That is what is called a specific heat capacity. So, its formula is Q divided by M into delta T. And this molar heat capacity and specific heat capacity are intensive property, but heat capacity is what? Extensive property. Okay. And that molar heat capacity, again we can discuss that constant pressure, molar heat capacity at a constant pressure as well as molar heat capacity at a constant volume. That Cp minus Cv equal to R, that is what is called a Mayer's relation. That also you learned. You have to keep that idea in mind. Okay. See, next again entropy. Entropy is the measure of randomness or disorderness in a system. That entropy, whenever solid is converting it into liquid, entropy is increasing. That entropy is an extensive property and a state function. Okay. So whenever solid means particles are closely packed. And whenever we are converting it into what? A liquid means what is happening that time? That time that particles are started to move. So their randomness is increasing. So we can find out only entropy change. Clear? Yeah. If this entropy change of the system we can calculate by using the formula Q reversible by T system, or else we can use delta H by T system. That formula also we can use. Now, according to second law of thermodynamics, entropy of the universe increases day by day during spontaneous process. So from that idea we are getting delta S total. Delta S total is nothing. Delta S total equal to delta S system. Delta S system plus delta S surrounding. Okay, delta S system plus delta S surrounding. Delta S system plus delta S surrounding, that is greater than 0. That is positive, meaning that is a spontaneous process. Spontaneous process means that process occur naturally. Clear? Yeah. And delta S total is less than 0. That means that process is a non-spontaneous process. Delta S total equal to 0, meaning equilibrium. listen, keep it in mind that you have to be alert like that what? This is delta S total, not delta S system, not delta S surrounding. Delta S total means delta S universe means delta S system plus delta S surrounding. That both, while you are adding, that value should be greater than 0. Okay? Yeah. So that's the idea. Next, again entropy change for an ideal gas. In the case of ideal gas, whenever there is expansion or compression like that happen means what's the entropy change? Entropy change is equal to, the formula is 2.303 NCV log T2 by T1. This CV means heat capacity, molar heat capacity at constant volume. T2 is the final temperature, T1 is the initial temperature, plus 2.303 NR log V2 by V1. Okay. Then if it is isothermal, isothermal means these temperatures are constant, T1 equal to T2. So this term won't be there. So the final terms only will be there. What will be the formula? 2.303 NR log V2 by V1. Clear? And the second case, isobaric. Isobaric means, see, here this V2 by V1. V2 by V1 is this one. Instead of that, I can write V2 by V1 is nothing. That's equal to P1 by P2. So anyhow, instead of this V2 by V1, I am writing P1 by P2. So that is equal. That both are equal means only first term will be there. 2.303 N into, here it is not constant volume, constant pressure, log T2 by T1. Like that the formula will come. And for adiabatic process means what? There is no heat energy is absorbed, there is no heat energy is released. So that time Q equal to what? 0. So automatically delta S equal to, we know, Q divided by T. So that Q is 0, automatically delta S surrounding is equal to 0. Clear? Idea okay? Yes. Next, Gibbs-Helmholtz equation. That is delta G equal to delta H minus T delta S. That Gibbs free energy is the energy available in a system to do some useful work. During a spontaneous process, that Gibbs free energy is continuously decreasing. That only we are telling delta G system is negative means that is spontaneous process. Delta G system greater than 0 means what is that? That is that what? Non-spontaneous. Delta G system equal to 0 means what? That is equilibrium. That idea you have to keep it in your mind. Clear? Yeah. We can go to the next idea, that is the relationship between delta G and Kc. So the relation is delta G equal to delta G0 plus RT ln Kc. This is the idea. This is delta G means Gibbs free energy change. This is the standard Gibbs free energy change. At equilibrium, this delta G equal to 0. Gibbs free energy change is equal to 0. That means left hand side equal to 0. So that is equal to delta G0 equal to delta G0. See delta G0 plus RT plus ln Kc. Okay, RT plus ln Kc. Therefore delta G0 equal to minus RT ln Kc. That only we wrote here, delta G0 equal to minus RT ln Kc. That natural logarithm I can convert it into common logarithm by multiplying with the 2.303. So minus 2.303 RT log Kc. In many times they asked questions related to this one. In JEE as well as many competitive examination, they usually used to asking questions from this area. Okay, keep it in mind. Delta G0 equal to minus 2.303 RT log Kc. Clear, DS? Yes or no? So that's the idea. Then here the last portion in that thermodynamics itself, you have to focus what? Thermochemistry. That means in chemistry, mainly the chemical reaction associated enthalpy changes we have to remember. So there, whenever you are having a reaction, along with that you are representing delta H, that kind of reactions are called thermochemical equation. That minimum idea you know. So whenever during a chemical reaction, how much heat energy is changing, that is what is called the enthalpy of reaction. That reactions may be many types. First one is formation. Formation means 1 mole of a compound is formed from its own elements. 1 mole compound is formed from its own element at a standard state. That time, during that time, how much enthalpy change is there? That is what is called the enthalpy of formation. Then whenever you are having a reaction, A plus B gives C plus D. A plus B gives C plus D. This is one compound, this another compound, this another compound, this another compound. We don't know what reaction it is. And its enthalpy of reaction if they are asking you to find out. What do you have to do? Sometimes they will give you what? Enthalpy of formation of this one. Enthalpy of formation of A. Enthalpy of formation of B. Okay. Enthalpy of formation of C. Okay. Enthalpy of formation of D. This much idea if they give means, then only I gave the formula. Enthalpy of that entire reaction is equal to enthalpy of formation of products. That products you have to add minus enthalpy, sigma enthalpy changes of what? Reactant. That reactants you have to subtract from that. If they are giving for a particular reaction, enthalpy of formations of the reactants as well as products are given, means that products enthalpy of formation you have to add some, then minus, subtract enthalpy of formation of what? Reactants. Then you will get the enthalpy of reaction. That idea is clear, yes or no? Yeah. Next, if the same case, enthalpy of combustion. Combustion means reaction with oxygen. All combustion reactions are exothermic except nitrogen's combustion, that is endothermic. That you learned already. So here, during combustion reaction with oxygen. So that time, whatever the reaction, okay, suppose any reaction, A plus B gives C plus D. Okay, all are what? All are compounds. A is a compound, B is a compound, C is a compound, D is a compound. And this is some reaction, okay, whatever the reaction. And in this case, they are asking to find out the enthalpy of reaction. That time, if they are giving the enthalpy of combustion of A, what is enthalpy of combustion? It is the amount of heat energy released when 1 mole of a compound completely reacts with enough amount of oxygen. Okay, and whenever A is reacting with oxygen, how much heat energy is releasing, that we know. And whenever B is reacting with enough amount of oxygen, how much heat energy is releasing, that we know. And if C is reacting with oxygen and how much heat energy is releasing, that we know. And if D is reacting with oxygen and how much energy is releasing, that we know, means then I can find out the enthalpy of reaction. That only we wrote here what? Sigma enthalpy of combustions of reactants. First I have to take the reactants enthalpy of combustion. I have to sum it. Minus sigma enthalpy of combustions of what? Products. Enthalpy of combustions of reactants minus what? Enthalpy of combustions of what? Products. Clear? Ready? Yeah. Next, again, if they are giving the bond energies for any reaction, see, N2 plus 3H2 reversible or else gives 2NH3. Suppose this is the reaction. Okay, this is the reaction. If they are giving the bond energies like N triple bond N plus 3 times H single bond H. Okay, that gives 2 times NH3 is like this. See, if you know the bond energy of, they will give N triple bond N, its bond energy they will give. H single bond H, okay, its bond energy they are giving. And its bond energy of NH bond, that also they are giving. Suppose this is X, this is Y, this is Z. Then how I can calculate? So the idea they given what? Enthalpy of this reaction. Enthalpy of reaction. Okay. Enthalpy of reaction how much? How I can calculate? Enthalpy of reaction is equal to sigma bond energies of reactants. Okay. Minus sigma bond energies of what? Products. So which all are the reactant bond energy here? 1 N triple bond N. So bond energy of N triple bond N plus how many H single bond H? 3. So 3 times bond energy of H single bond H. Clear? And minus of bond energy of product. So here in bond energy, how many bonds are there? 1, 2, 3. 3 NH bond in 1 NH3. Like that 2 means 6 bond energy of NH. So we can give the value. Bond energy of N triple bond N is how much? That is X. So X plus, what's the bond energy of HH bond? HH bond is Y. Like that 3. So 3Y minus, what's the bond energy of NH? Z. So 6Z. Like that they will give the value, means you can easily find it out. Clear, dears? So that's all about the chapter what? That's all about the chapter thermodynamics. And finally, one more concept we have to learn from there. That is what is Hess's law. Hess's law means, Hess's law states that Hess's law of constant heat summation states that whether the reaction takes place in single step or multiple step, the total enthalpy change is a constant. That means you remember, whenever I am having a solid, I am converting this solid into liquid at its melting point. Then that enthalpy change is called enthalpy of fusion. Enthalpy of fusion. And this liquid I am converting it into a gas. That time enthalpy change. Enthalpy associated is what? Enthalpy of vaporization. Enthalpy of vaporization. And if I am converting solidity into gas. That is what is called enthalpy of sublimation. Then according to Hess's law, if a reaction takes place in single step or in multiple step, the total enthalpy change is a constant. Meaning delta H fusion. Okay. Delta H fusion plus delta H vaporization. That will be equal to delta H sublimation. This is what is called Hess's law. That's all about the chapter thermodynamics. So that related Hess's law related a lot of questions you can see. You have to practice maximum number of questions. This is the basic ideas related to thermodynamics. You just go and do the maximum questions from thermodynamics. Okay, damn sure about that. Try to practice maximum previous year questions also. Then you will get the ideas. Okay, so now let's look about the next chapter. That is what is equilibrium. So equilibrium is also very important topic for the JEE examination. Here, see, mainly the things you have to focus is equilibrium constants like Kc, equilibrium constant in terms of concentration, equilibrium constant in terms of pressure Kp. Then their Kp Kc relation, Kp equal to Kc into RT raised to delta Ng. Then applications of equilibrium constant, Le-Chatelier principle. Then ionic equilibrium. Ionic equilibrium is a big portion. From that, so many equilibriums, so many ions related equilibriums you are learning. For that, the main basic idea behind it is the degree of ionization, then acid-base concept, then Kw, equilibrium constant of water, equilibrium constant of weak acid, equilibrium constant of weak base, then pH and pOH idea, then salt hydrolysis idea, then common ion effect, buffer solution and solubility product. These are the important areas. So that related, instead of reading the theory again, you have to practice more question, means it will be easy for you. Correct? Yeah. So we can look about one by one. First of all, Kc and Kp relation. Okay. Kc and Kp relation. Kc is the equilibrium constant in terms of concentration. Kp is the equilibrium constant in terms of pressure. That idea we know. Okay. For a general reaction, if we are having AA plus BB, that reversibly gives what? CC plus DD. Okay. For this reaction, if it is a gas, and this is a gas, this also a gas. Okay. All are gases. Then what about the equilibrium constant in terms of concentration Kc? Kc equal to concentration of C raised to C into D raised to D divided by, that means products I have to write first, then their stoichiometric coefficient I have to raise their powers, equal to concentration of A raised to A into B raised to B. Okay, that idea we know. Okay, clear, ready. So A raised to A into B raised to B. And what about Kp? Kp equal to, in terms of pressure, if you are telling, means that should be a gas. So partial pressure of C. Instead of concentration for gas, we will tell what? Partial pressure. Partial pressure of C raised to C into partial pressure of D raised to D. Okay, raised to D divided by partial pressure of A raised to A. Partial pressure of A raised to A into partial pressure of B raised to B. Partial pressure of B raised to B. Like that I can write. That Kp and Kc relation we wrote what? Kp equal to Kc into RT raised to delta Ng. What is delta Ng? That we discussed in the thermodynamics, same. Number of moles of gaseous product minus number of moles of gaseous reactant. So what's the delta Ng here? Number of moles of gaseous product. How many gaseous product are there? C plus D minus what is the number of moles of gaseous reactants? A plus B. Okay, A plus B. This is the idea. Clear? Ready? Yeah. So one more thing you have to remember from that Kp equal to Kc into RT raised to delta Ng. From there, three cases also you have to remember. Case 1, if delta Ng equal to 0, then what will happen? Kp equal to Kc. Kp and Kc are equal. Okay. And case 2, if delta Ng less than 0, delta Ng is negative, means that RT, that will come downside, Kc by RT will come, RT raised to something. So that means Kp value will be less than Kc will come. And case 3, what about case 3? If this delta Ng value is greater than 0, 1 or 2 or 3 or 4, okay. So that time means Kc into RT raised to a number. So Kc into some number you are multiplying, you are getting Kp, means Kp value is greater than Kc. That's related questions they can ask. You have to keep that idea in mind, okay. Ready. Then next idea from here we have to remember about the applications of equilibrium constant. We must have to know equilibrium constant is a constant that depends mainly on the temperature as well as the mode of representation of a reaction. Yeah, see here, whenever we know the value of Kc, then predicting the extent of reaction, we can predict the extent of reaction. If Kc value is greater than 10 raised to 3, 1000, Kc value is greater than 1000, then the reaction go almost completion. Meaning Kc is bigger value, means what is Kc? Concentration of C raised to C into D raised to D divided by A raised to A into B raised to B. That product divided by reactant. That product value is more, meaning reactant value is less, meaning the reaction is going to almost completion. And if Kc value is less than 10 raised to minus 3, meaning product is less, reactant is more, meaning that reaction just start, that only the reaction proceed to a very small extent in the forward reaction. That means reactant is more. And what about Kc value in between 10 raised to minus 3 to 10 raised to 3? That concentration of reactants and products are comparable at equilibrium. That's the idea. And second thing, if we know the Qc, what is Qc? Nothing. Same expression for Kc, but other than equilibrium. That means the concentration of C raised to C into D raised to D divided by A raised to A into B raised to B. That concentration terms, ratios, okay, that ratio value other than equilibrium, that is what is called Qc reaction quotient, that you know. That Qc value is greater than Kc, then backward reaction will take place. Because everything are trying to attain to equilibrium. So Qc is greater means that product they will try to reduce. That only it can become equilibrium constant. So backward reaction will take place. And if Qc is less than Kc, then that product they will increase. That means forward reaction will increase. And if Qc equal to Kc, that is what is called equilibrium. That related questions, okay, should be there. That idea you have to keep it in mind. Next again, Le-Chatelier principle. What is Le-Chatelier principle? If a system is in equilibrium, is subjected to any change in concentration, pressure, temperature, etc., the system will try to oppose the change, cancel the change, by shifting the reaction either in forward or else in backward reaction. That is what is called the Le-Chatelier principle. Whenever you are increasing the temperature, system will try to decrease it. Whenever you are increasing the pressure, the system will try to decrease it. Whenever you are trying to increase the concentration, the system will try to decrease it. Whenever you are trying to decrease it, the system will try to increase it. So just opposite. That relation and applications, I just made it as a column. You already learned. If you are increasing addition of reactants, that means increases the concentration of reactants. What will happen? Forward reaction will favor. Because that they will try to decrease it means forward reaction. And removal of product, if you are removing product is decreasing, the system will try to increase it. How they can increase? Forward reaction. And in the case of concentration addition of products, if you are adding products, the system will try to decrease it, backward reaction. And if you are removing the reactants, backward reaction. Okay, yeah. Next, what about the pressure? Pressure is mainly due to the collision between the gaseous molecules. So whenever collision is more means pressure is more. So whenever you are increasing the pressure, system will try to decrease it. Whenever you are increasing the pressure, that means you are increasing the pressure means collision is, whenever collision increasing, so that time the system will try to decrease it. So equilibrium is shifted towards a lesser number of gaseous molecules. Gaseous molecule, okay, gaseous molecule, that is very important. And if you are decreasing the pressure means system want to increase it. Increase, how they can increase it? So by increasing the collision. Increasing the collision means equilibrium shifted towards the more number of gaseous molecule. More number of gaseous molecule. And one more thing you have to remember there, if delta Ng equal to 0 means pressure has no effect. Pressure has no effect. Okay, yeah, that's the idea. Next again, temperature. Whenever you are increasing temperature, the system will try to decrease it. How they can decrease it? How they can decrease it? Temperature, whenever you are increasing, how they can decrease it? By absorbing that heat energy. That is what is called endothermic reaction. If you are decreasing temperature means the system will try to increase it. How they can increase it? By emitting the heat energy. That is what is exothermic. So that idea only I wrote here. You can see increase in temperature. This equilibrium shifted towards forward direction. If the reaction is what? Increase in temperature means for endothermic reaction. For endothermic reaction, that will be shifted towards the forward direction. And increase in temperature for exothermic reaction, equilibrium shifted towards the backward direction. Okay. You have to remember only this idea. When temperature increases, which reaction will take place? Temperature increases means endothermic will take place. That's the idea. Endothermic will take place. Temperature decreases, which reaction will take place? Exothermic will take place. Exothermic will take place. That two ideas you have to remember, then you can answer it. And if you are adding inert gas at a constant volume you are adding, no effect. But at a addition of inert gas at a constant pressure you are adding means equilibrium shifted towards more number of gaseous molecules. Okay, that direction. And catalyst have no effect. Catalyst will bring the reaction equilibrium very fastly into equilibrium. That reaction fastly into equilibrium, quickly into equilibrium. Okay, that's the idea. That's all the idea about the chemical equilibrium. Next, we have to remember about ionic equilibrium. Ionic equilibrium means it is the equilibrium between unionized molecules and ions. For that is mainly given by the weak electrolyte. A strong electrolyte will completely dissociate. It will be irreversible reaction. A weak electrolyte like weak acid, weak base, like that. Okay, suppose I am taking AB, that will partially they will dissociate to give you A plus and B minus. That will combine together to give you unionized molecule AB. That time we must have to tell how much percentage of particular electrolyte is dissociated, ionized. To tell about that one only, to express that only, we are having degree of ionization alpha. Alpha equal to number of moles of electrolyte ionized. Okay, divided by total number of moles before taking. Suppose I am taking 100, out of that 3 only dissociating, means its alpha is equal to 3 by 100. Alpha equal to 3 by 100. If you want to tell in percentage, means into 100. So this alpha value maximum 1, that is for strong electrolyte. Okay, for strong electrolyte. For strong electrolyte, and for weak electrolyte, alpha value will be very much less than 1 for weak electrolyte. That idea you have to keep it in mind. Okay, dears? Clear? Yeah. Next, from here you have to remember about acid-base concept. That's a very repeatedly asking question. In the case of Arrhenius concept, acid means it gives H plus ions in aqueous solution, like HCl, HNO3, H2SO4, like that examples. Okay, yeah. Next, base means it gives OH minus ion in aqueous solution. So aqueous solution, here water is a solvent. Here water is a solvent. Okay, OH minus giving your NaOH, CaOH twice, etc. Are the example for what? Base. Okay, clear. Next, in the case of Bronsted-Lowry concept, acid means proton donor, H plus donor, and base means proton acceptor. Here they are not mentioning about the solvent. Okay, simply they are donors. Okay, and the substance which can donate acid and base, they are what is called what? They are called amphiprotic or else amphoteric. Amphiprotic or else amphoteric substance. According to amphoteric. According to Bronsted and Lowry, water is a amphiprotic. It can donate as well as it can gain. One more idea, whenever acid is donating H plus, then it will form a species, that is what is called a conjugate base. And whenever a base is gaining one H plus, then it is forming a species, that is what is called conjugate acid. That idea also you remember. That conjugate acid base pair differ by 1 H plus. One more thing, if acid is strong, means that conjugate base should be weak. Vice versa. That idea also you learned. Next, Lewis concept. According to Lewis concept, Lewis acid means electron pair acceptors. That means electron deficient molecule like BF3, AlCl3 and positively charged ions, etc. And here Lewis base means electron pair donors. All negatively charged species, as well as what? Lone pair containing electron rich molecule like ammonia, H2O, CO. That ligands we learned in coordination compounds, that all are belongs to what? Lewis bases. Clear, dears? Yeah. Next, from here you have to remember about pH, pOH, pKa, pKb. Okay, pKa and pKb. pH is the potential of hydrogen. That related calculation, how to calculate the pH of a solution, how to calculate the pH of an acid, base, etc. That we already did one video in the Brilliant Qatar YouTube channel, that you can check it. Okay, we will pin that particular video along with this one. Okay, you can check it. Okay, so pH equal to minus log concentration of H plus, pOH is equal to minus log concentration of OH minus, pKa equal to minus log Ka, that's for weak acid, pKb equal to minus log Kb. That's the idea. So whenever you have to remember, whenever Ka value increases, pKa value decreases. So that time acidic strength increases. And whenever Kb value increases, pKb value decreases. pKb value decreases, basic strength increases. That idea you have to keep it in mind. That related questions also repeatedly they were asking. Okay, see, next one, salt hydrolysis. There are different types of salt. Whenever you are adding salt, you are adding water to salt, that will form, that will be becoming ionized. That ions can either go and react with the water, that is called hydrolysis. Sometimes that ion will go and bind with, hug with the water molecule, that is called hydration. So only the weak part of the salt, weak ion from the salt only will go and react. Strong ions will always go and chill. Always go and bind with the water molecule. So here, in the case of salt of weak acid and strong base. What about weak acid and strong base? That is example is CH3COONA. Okay, so that one, its pH we can calculate. Its pH will be, that salt solution will be always basic because base is strong. So its pH will be greater than 7. 7 plus half into pKa plus log C. Here the weak acid, so that's why pKa plus log C. And if reverse, weak base plus strong acid, NH4Cl. Okay, its pH if you want to calculate means that should be less than 7 because acid is strong here. So 7 minus half into here base is weak, pKb plus log C. And if both are weak, acid and base are weak, and then the salt, example like CH3COONH4. Okay, this salt. That salt pH we can calculate like by using the formula 7 plus half into pKa minus pKb. And in the case of salt of strong acid plus strong base, they won't undergo hydrolysis. Their pH will be equal to what? 7. Strong acid, strong base. For example, NaCl, their pH we will calculate like what? pH equal to 7. Okay, that idea you have to keep it in mind. Next is common ion effect. What is common ion effect? It is the suppression of dissociation of a weak electrolyte by adding a strong electrolyte, both containing common ion. See CH3COOH. It is a weak electrolyte. Okay, it is a weak electrolyte. How it will dissociate, dears? How it will dissociate? That CH3COOH will dissociate as CH3COO minus. Okay, and H plus ion. Then they will combine together. They will give back the unionized CH3COOH. Now they are in equilibrium. This is a weak electrolyte. Already its dissociation is less. Now what I am going to do? I am going to add a strong electrolyte, CH3COONA. It is a strong electrolyte. Okay, it is a strong electrolyte. This strong electrolyte will completely dissociate CH3COO minus and Na plus. Now what will happen? There is a common ion is there. So CO minus is a common ion. So what will happen? The concentration of CH3CO minus will increase. According to Chatelier principle, backward reaction will take place. So what is common ion effect? It is the suppression of dissociation of weak electrolyte. That weak electrolyte dissociation we are suppressing by adding a strong electrolyte, both containing common ion. This is what is called a common ion effect. Its application only what? Buffer solution. What is buffer solution? Buffer solutions are the solutions which can resist the pH change. Even if we are adding a small amount of acid, strong acid, a small amount of strong base to it. Or else if we dilute it also, that pH change they will resist. That kind of solution is called what? Buffer solution. That buffer solutions are mainly 3 types, which are the simple buffer. Simple buffer means it is the solution of salt of weak acid and weak base. Okay, salt of weak acid and weak base. That means CH3COONH4. That is what? Simple buffer. And what about acidic buffer? It is a mixture of weak acid plus salt with a strong base. Okay, or else we can tell like that weak acid and its conjugate base. That's it. Weak acid and CH3COOH and its conjugate base containing salt, which is that CH3COONA. The conjugate base is CH3COO minus. That containing salt is CH3COONA. And basic buffer means weak base and its salt with strong acid. For example, NH4OH, weak base and its conjugate acid containing salt. What is that? NH4Cl. So that is the basic buffer. To calculate their pH, we are having formulas. For a simple buffer, weak acid plus weak base salt is pH we know 7 plus half into pKa minus pKb. For the case of acidic buffer, pH we can calculate by using the formula pKa plus log concentration of salt divided by concentration of acid. This equation is called what? Henderson-Hasselbalch equation. Or else for basic buffer, POH we can calculate by using the formula pKb plus log salt by base. And if you know the POH means pH equal to 14 minus POH. Like that we can calculate. Ready? And the next idea is solubility equilibria. That is mainly for what? Mainly for sparingly soluble salt. Sparingly soluble salt means their solubility is less than 0.01 molar. Very less solubility, they are very less soluble in water. They can form a equilibrium. Okay. For example, if you are taking AgCl, their solubility is very much less. Okay. That is a solid that will make an equilibrium like Ag plus Cl minus. This in aqua, in water. Then what about the equilibrium constant for the sparingly soluble salt? Concentration of Ag plus into concentration of Cl minus divided by concentration of AgCl. That's a solid, that is 1. This ionic product, that is what is called a solubility product. Solubility product is nothing but it is the product of ions produced by the sparingly soluble salt, and we have to raise some powers that will be equal to its stoichiometric coefficient of the ions. If your ion is like this, see, if your sparingly soluble salt is AXBY, how it will dissociate? It will dissociate like X number AY plus as well as Y number BX minus. Then solubility product KSP equal to the ions, product of ions, AY plus into BX minus, they are raised to X as well as Y. Then that relation, KSP-S relation, solubility relation, if its solubility is S, then its solubility is XS, its solubility is YS. Then you can relate them. This is XS raised to X, this is YS raised to Y. Then X raised to X, okay, into S raised to X, Y raised to Y into S raised to Y. So X raised to X into Y raised to Y, S raised to X plus Y. So you can get a relationship between KSP and S. That related questions will be there. You have to remember that, okay. And next idea, common ion effect on sparingly soluble salt. Suppose you are having a sparingly soluble salt, AgCl, see, AgCl, that you are going to dissolve in NaCl, okay, NaCl, 0.1 molar NaCl, if you are going to dissolve that one, then what will happen to its solubility? Its solubility will decreases. Why it is decreases? Because of the common ion. So whenever a common ion is there means its solubility will decreases. That related calculation problems also they usually used to ask. So you have to practice the problems. Okay, you have to practice so many problems, DS. That's all about the chapter equilibrium. So you have to go through, you have to do a lot of questions, and wherever you are feeling difficulties, that area you just comment in the comment box. We will make the videos related to that. We have to crack the JEE this year itself. We have to go to NIT, we have to go to IIT. Ready? Are you ready, guys? Yeah. So see you in the next video. Next video is the recap, 8th video, last video. So wait for that. Up to that, thank you.